middle school, high school, early career, I was very interested in math, but not so much in chemistry. So I chose the one thing that actually one science that doesn't actually involve math. There are many choices that I made that I wish I had maybe made differently.
Hi everyone, we have with us Professor Forrest Michael today, and he pursued his undergraduate studies from Pennsylvania State University, and then he moved to pursue a PhD from Harvard University where he worked on palladium catalyzed reactions. He is currently a professor of chemistry at University of Washington, where he has been working on developing main group catalysis by studying selenium catalyzed reactions. We are very excited to have you here today, sir, and ask you some questions that we have.
Thank you. It's great to be here.
So, sir, we would love to know what first drew you to chemistry and when did you decide to pursue it professionally?
Yeah, that's an interesting question. So most of middle school, high school, early career, I was very interested in math, but not so much in chemistry or science or things like that. So I assumed that when I went on to have my career or went on to college that I would be doing something in mathematics. That's what I thought was really interesting. So I was a little bit surprised to find that when I actually got to college and I took my first chemistry class, that I thought it was really, really fascinating. It was an organic chemistry class, and I decided pretty much on the spot, within the first week of classes, that was what I really wanted to make my career out of. And it wasn't really super clear at first what it was that drew me to organic chemistry. It's a little bit ironic since organic chemistry does not have a lot of math in it. And so I chose the one thing that actually one science that doesn't actually involve math. But I think what really drew me to it was just this idea that you could have an intuition, that you could have this mental picture of what it is molecules were doing and what they what reactivity they like to engage in without ever actually seeing the things. And so you could have this mental picture and understand at a very fundamental level how things work and how molecules rearrange without actually ever having to see it. It just these pictures kind of flashed into my head, and I thought that was very, very interesting.
So you do have a BS in mathematics as well.
That's right.
And as you said, those two subjects are never considered connected to each other by most students. But
yes.
Is there something from your mathematical studies that has helped you in approaching problems in organic chemistry?
Yeah, very much so. It is much more of a philosophy of thinking than it is actually using math skills on a regular basis. I mean, we do some computational chemistry, which does involve needing to know some mathematical concepts, but it's much more about logical thinking. And mathematics is, a beautiful playground for mathematical thinking and logical thinking. So essentially, I apply those concepts, even though it's not mathematics per se. It's just sort of that logical deduction. And it's really important when thinking about chemistry because logical deduction is essentially the only way we get to understand how chemistry works.
Yes, sir. So, sir, as undergrads, we have a lot of options. And since chemistry is a very vast field, what is something you wish you had known as an undergrad researcher that you believe would have helped you more?
That's an interesting question, and I'm not sure that I have a great answer because I feel like a lot of the lessons that you learn throughout the course of your academic career, undergraduate, graduate level, academic positions, are lessons that you kind of have to learn by experience. There are many choices that I made that I wish I had maybe made differently, and there's many pieces of information or philosophies of how to approach decision making and that I did wish I knew. But I also don't think I would have taken it to heart. It's the kind of thing, it's a lesson that only comes, only really deeply comes when you make those choices and you make those mistakes yourself. And I've always kind of fundamentally believed that I prefer to learn by making my own mistakes. And it's a painful way to learn sometimes, but I feel like those things that I do learn are much more hard won. I feel much more satisfied about them.
Yes. So it's definitely useful to have very diverse experiences as an undergraduate student and even beyond that.
I believe so, yes.
So along those same lines, you have been interacting with a lot of students and researchers all around the world. So could you please share something about the program that you're involved in that helps you be at these many places and interact with students even from high schools?
You mean this program that
Yes, sir.
I am here for in Bangalore?
Yes, sir.
Yes, so it's a program that I have been working with for a long time. It's called the Research Science Institute. And it's a program for high school students to essentially get real experience in research projects. And so we have a program that we started a long time ago that I was actually part of when I was a high school student, and has been run out of MIT, where we bring in students for 6 weeks. And then we were invited to come to India to inaugurate a program here, the Research Science Institute in India, that's operated out of the IISc in Bangalore. And the program involves first week of classes where students can learn chemistry, math, biology, and humanities. And then after that, they spend 5 weeks in actual labs doing real research projects, and then they write a report and give a presentation. And so I've been with this program for many years. This is the second year I've been with the India program. And it's really rewarding and satisfying program to get to see, to bring in high school students who are really excited about science and give them an opportunity to taste what it's like to actually do that real science. Because the experience itself is sometimes very different from your expectation of that
Yes, sir.
experience.
Yes, sir. Such programs are definitely very useful for undergraduate students and even students who are younger than that, students in high school looking to see what they want to do with their careers. So it's really nice to know that there are more and more such initiatives for students that they can avail nowadays.
Yeah, that's great.
Okay. Thank you, sir. These were all the questions I had.
All right, thank you so much.
Thank you so much, sir.
So, sir, if you had not chosen organic chemistry, then is there any other field you think you would have enjoyed working in?
Yeah, that's a great question. I definitely thought about some other options. As I mentioned before, mathematics was always very fascinating to me, and so I thought I might pursue a career in math. And I also had a lot of interest in engineering and understanding sort of how to build things out of science. But choosing between math and between science and engineering, for me, I always like the fundamental understanding a little bit more than the actually building things from it. I just get this really, deep sense of satisfaction when I can look at something and answer the question, why does it do this? How does it work this way?
Okay, so when a reaction doesn't work or a project repeatedly fails, so how do you decide whether to keep pursuing it or move on?
Honestly, that is one of the most difficult parts of my job, is to decide when a project we need to move on from a project and when we need to just continue attacking a project. Because as I'm sure you're aware, every project runs into roadblocks and every project has times where it doesn't work. And sometimes the most exciting projects, and the ones that are most satisfying when you complete them, are the ones in which you have to solve the most problems. And so it's always good to keep attacking, especially if it's something that I'm particularly excited about. But ultimately, of course, projects fail and we only have a limited amount of time. So how do I make that choice? It is really very much based on instinct, and it's really based on conversation with students about how they feel about that project and whether or not they feel like they're continuing to make progress. And because I find that the motivation to attack the problem and the motivation to solve it is really the only thing that gets us closer to the finish line. And so we have conversations about this on a regular basis. Are we making good progress? Is it time to think about a different idea? And the answer is really never, we're just going to quit this because we feel like it's not worthwhile. But the answer is, do we have something more important we'd rather be doing with our time? Have we decided this project is going to occupy too much time relative to another project that we are equally excited about? But it's a very, very difficult decision, and I get it wrong all the time.
Okay, like mine is like almost failing from like last 2-3 weeks. So okay. So before we wrap up, so what advice would you give to a student who hopes to build a long-term career in research or academia?
I think the best advice I have is to find something that you're excited about doing and to just work really hard at that. There's no replacement for just putting in the effort and putting in the motivation. And I am really always sort of inspired by scientists that we think of as incredibly brilliant, who, when you ask them about it, you can find quotes from them, and most of them will tell you that what led to their success was not natural talent. It was not the fact that things came easy to them. It's not the fact that maybe they got lucky, although luck always plays an important role. But for many of them, they do expressly admit that it was really just about persistence. It was about continuing to pursue projects and answers even when it got difficult. Louis Pasteur has a quote along these lines. Richard Feynman has a quote along these lines. Many, many famous scientists will admit that it's the passion for the science that really gets you to the finish line.
Okay. So thank you so much for your time and your valuable insights. It was truly pleasure speaking with you today. We really enjoyed learning about your journey, your research, and your career, perspectives on scientific discoveries. We really hope to have you in future in IISER Bhopal again.
Thank you so much. It's been a wonderful visit here, and it's been great to meet with all of you and to hear all of your fantastic questions about science.
Thank you.